Welcome to the classroom. Today we're going to Midland, Ontario to look at deposition of sediment from flowing water. You don't need a lot of water to move sediment. You can see in this little clip here that there's a small little channel that is creating some erosion. You can sort of see this erosional cup area with a very small channel about the width of my hand and even smaller flowing channel where you can see the sediment eroding away, the light and dark particles washing through the water. And that is being deposited further downstream. As the channel pathway, we get corners. So on the inside of the corner, we actually get deposition of sediment. On the outside of the corner, we get erosion happening. And you can see in the banks of this small channel lots of beautiful horizontal beds. These are bedding planes from past deposition. In bigger storm events, there could be more water flowing through this channel. As you can see, it's much wider and the water's flowing in a narrower portion of the channel. We have different terraces. These are the flat areas on either side of the bank where the water isn't flowing. Now, if it floods, it may flow over into those terraced areas, but those terraces mark past flowing water levels and the channel's cut down, and as the water volume decreases or its energy decreases, the pathway gets narrow. The stream or river channel gets narrower and we cut down further. On the side of the terrace, it's like a cross section through the ground. We see these beautiful horizontal layers that are traces of the past deposition. You can see the light and dark layering alternating. There's blacks and grays and browns, marking different types of sediment that has been pulled along. If we go back and we look at the flowing water, we can see light and dark particles being deposited in the river channel itself. Now, in the river channel, you can see different small islands that are left behind. So the pattern is sort of mottled texture, light and dark patches. But if we take a horizontal slice through there, we see layers nearly continuous in that cross section of a dark band, and then on top of that, a lighter band, and alternating depending on the type of sediment being deposited. And that's very useful for our engineering purposes. One of our laws of superposition and a law of lateral continuity. Those horizontal beds are continuous unless disrupted by something else. Now, they could be disrupted by movement of the channel and deposition in a different area of the channel and so on. It allows us to consider those continuous layer within the channel. And we can use that to make our geological model and help us to predict where spatially those layers may exist. And that can be useful for trying to find aggregate, but also for engineering purposes, trying to construct something that may want to cross such a river channel. We can understand where the weak layers may exist and how deep we may need to anchor things or drill in our piers to make our bridge foundation strong enough and durable enough. So all these things are part of the engineering considerations where we may want to understand where spatially the beds exist, and that is all related to the depositional environment, which you can see here. Thanks for watching.